to try and build the world's largest Raspberry Pi supercomputer. And I'm going to tell you a little bit about what that is and what that involves. So over these 4 videos, I'm going to talk about networking, which is something that's essential to bringing computers together to solve problems. We're going to talk about MPI, which is a message passing interface, and it's a program that allows for supercomputing to happen. And I'm going to talk about the programming applications of supercomputing technology. A supercomputer, or computing cluster, is a collection of computers that work together to solve a problem. This is otherwise known as parallel processing. Now, most modern-day computers do a form of parallel processing called SMP, or simultaneous multiprocessing. This is seen in most multi-core computers, such as an AMD quad-core computer, where there are 4 processors all working on running all of your programs and applications that are running on the computer. So this is an example of shared memory computing. And what it means is that you may have multiple processors working in parallel, but each processor is acting on a shared memory. And they all have, in memory, the same problem. So they all have the same information. Now, there are a couple supercomputers in the world that work like this. However, it can be slower because now your bottleneck is between the RAM and the CPUs. So because these systems are also very abnormal and you can't take advantage of consumer parts such as regular workstations to be part of your supercomputer, it's much less common and it's more expensive to implement. That is why most modern supercomputing installations favor distributed memory computing. And that's what we built here today. Distributed memory supercomputing works where you have each and every processor takes a part of the problem, it stores it in memory, and then once it's got that part, it works on that part. And then it sends its results through the network back to the master node, or the master computer that's coordinating all of this operation. What we have so far is an understanding of distributed and shared memory supercomputing. So what we've built here is a distributed memory supercomputer, which runs off Raspberry Pis as the individual computers. And the individual computers in a distributed system are normally referred to as nodes, because each node is an independent personal computer with its own set of RAM, its own network card, its own processor on its own motherboard. So each one is kind of independent from each other. So this makes them very expandable, as you just buy more computers and you put more in. What Raspberry Pis can do is they're very low power and very cheap devices, which means we can have a very large computer with many individual nodes for quite a low cost. So this is very advantageous when you're trying to learn about supercomputing and trying to learn about how to program large programs that involve lots of different nodes and coordinating all of them. So what is a Raspberry Pi? A Raspberry Pi is a small Linux computer. It runs on Debian, and it uses something called an ARM processor. And an ARM processor is essentially one of the newest chips around, and it's a very low-powered chip. It's used in mobile phones, iPhones, Samsung Galaxy Force. They all have ARM processors in them. This ARM processor is made by Broadcom. And that little chip in the middle of the board, it has on it a GPU, a CPU, and all of the Raspberry Pi's memory. So the Raspberry Pi, in terms of specs, isn't that great. It's got about 512 megabytes of RAM. It's got a 700 megahertz processor that can be overclocked to 1.2 or really 1 gigahertz. So it's not very fast. And it's all built onto that one little chip, which can get hot. So you have to be careful with them. In terms of memory storage, you can't store that much on them. You can get, a 16 or 32 gig SD card, but the rest you're going to have to run off external through its 2 USB ports. But what makes the Raspberry Pi so great for supercomputing is the fact that it has a network interface. And you can actually use it to communicate over a computer network using Ethernet cables and switches and routers. And it also runs a full version of Linux Debian, which allows you to install programs that were originally written for 32-bit computers, large workstations, on this little ARM chip. So it means we can run a whole bunch of programs and a whole bunch of protocols that are industry standard for larger supercomputers, which helps us learn more about supercomputers because we are actually using something that could be implemented on a larger, much more expensive computer. But what are we going to do with the world's largest Raspberry Pi supercomputer? What we're going to do is we're going to use it to learn about supercomputing. We're going to try and understand how supercomputers work, how to program supercomputers, how they're networked, and all that stuff. And what it'll allow us to do is when we leave school and if any of us do get a chance to work on supercomputers, we'll have a background understanding, and it'll bring computing to a much more approachable level. As before, building a 64-node supercomputer cost $30,000. If we can do it for $4,000, that's a big bonus. Anyone could try this. 3 Raspberry Pis, 4 Raspberry Pis put together into a supercomputer, that's $300. Anyone can do that. I mean, it's a small amount of money to pay, and you can get a lot of educational value out of each individual Raspberry Pi. In the next video, we'll be talking about networking and the ways in which the computers talk to each other. Thanks for watching.